Welcome to Videos by Rosinski Productions. This video brought to you by Pit Bulls and Polyatomics. Let's get going on this topic. The topic of today's video, lab equipment. So, we have safety rules. You have a safety contract. Now we need to be able to actually identify the equipment. And in Friday in class, you're actually going to have to hunt it down and find it in the classroom. First major piece of equipment that you will use in almost every lab is a beaker. They come in multiple different sizes. We have 50 milliliters all the way up to 3,000 milliliters. Notice one of the biggest things that you will notice, the size of the beaker is not necessarily going to match up with the gradations in the beaker. So when I say grab a 250 milliliter beaker, look for the entire size of the beaker, but realize we're only going to be able to put up to 200 milliliters in that. Beakers are not used to measure volume. Only run reactions and carry different things in. Again, do not use to measure volume. Erlenmeyer flask, very similar to beakers, except obviously they have a little bit of a triangular shape. The reason for this is we're going to use flasks for two different purposes. One, if we need to heat up a reaction and we're concerned with stuff splattering out, this triangular shape stops it a little bit. The other use of a flask is that we will put a stopper inside of it and make solutions that if we need to hold on to them for a couple days. So flasks, same thing as a beaker, not used for volume. They'll tell you their max size right on it. Most of them will also have gradations. But we're going to use a flask if we're heating things and worried about splattering, or if we're going to make a solution and hold on to it. A Florence flask. This is a flask that you guys probably won't use in this class. They're also known as round bottom flasks. See the round bottom. Again, just another different type of flask with a very, very narrow neck. Obviously, probably not going to use it. There is one other type of flask called a volumetric flask, which is a very precise instrument that measures. It only has one gradation on it that measures perfectly to the volume. I'll be using those behind the scenes, but you will not be using those in class. But you do need to know Erlenmeyer flask and a beaker so far. Graduated cylinders. We have different sizes in the classroom. We have 10, we have 25, we have 50, and we have 100 milliliter graduated cylinders. Notice that unlike the beaker, there are plenty of gradations on these beakers, or excuse me, on the graduated cylinders. This is what we use to measure volume. Measure volume. Only in a graduated cylinder. It is the most precise instrument we have in the class to do that. You will not mix chemicals in these. You will not run a chemical reaction in it. This is used to just measure volumes. From here, it normally goes into the beaker or a test tube, but graduated cylinders measure volume. Test tubes. We have different sizes. The sizes are actually, what you're seeing here is the diameter of the opening versus the length. We'll normally have these large test tubes. Hint for the scavenger hunt, they're actually in a box in the bookcases nearest the emergency exit. So for those of you that actually watch this, that is where our test tubes are hidden. They're actually in a box near the emergency exit in the back right corner of the room on the bookcases. Test tubes are used to run small scale experiments. We'll actually mix chemicals inside of these. We can heat things in them, but again, not used to measure volume, but we can run some chemical reactions inside of it. Test tube holder. Take a look at that test tube. It's round. If you're heating it, you don't want to touch it. Glass conducts heat. So we have a test tube holder. You want to hold it here. This actually works by you squeeze there to open. So the problem is if you get excited and you squeeze, the test tube falls out. So you want to hold it here, less heat conduction and no accidental squeezing to open it up, but this is a test tube holder. Test tube brushes. They're exactly what their name sounds, brushing test tubes. We need to clean everything. Another helpful hint for the scavenger hunt, something called Alkanax. This is also found near the bookcases. This is a detergent. Hopefully we all know what a detergent is, also known as it cleans things. Okay, it's a powder that we use to put into the test tubes, into the beakers to clean stuff. But Alkanax, it is a powder, not a piece of equipment. Just another helpful reminder for the scavenger hunt upcoming. Test tube racks, again, common sense, it's a rack. It holds a test tube. They're found in, again, the bookcase in the upper right-hand corner. For those of you actually listening and paying attention, ours look like this, but they're made of the white plastic. So you're looking for the test tube on the right, but out of white plastic. Again, because it's made out of plastic, you do not want to put heated test tubes on it because it will melt it. So just be careful when you're using the test tube racks. Rubber stoppers. These, some have holes in them like this one, where we're able to insert different glassware or thermometer. Others, solid pieces. They're going to be placed in those Erlenmeyer flasks to hold the solutions. One thing you do not want to do is ever heat something with a rubber stopper in it. Spot or well plates. Ours actually look like white plastic. They're called well plates because they're all of these tiny little wells in them. They're used to run small scale experiments. And again, white plastic. They're used to run many, many small experiments at one time. Watch glass. I like to call this the contact lens of the Cyclops. It looks exactly like this picture. It's a gigantic glass contact lens. We'll run some small reactions on it or be able to carry some small solids on it. And we'll also use it on top of beakers when we're heating to make sure it doesn't splatter out. Glass stir rods. If you are a lucky class that is able to get all of your safety contracts in, you'll be actually making your own glass stirring rods, being able to actually bend glass, melt glass, and shape it. But these are obviously used to stir, and they're made out of glass. Forceps, you might call these tweezers. Same thing, they pick up small objects. Funnel, again, same idea in real life. Please bring your common sense to the lab. From a large open vessel of liquid into a smaller vessel, we will use a funnel to make it transfer easy without splashing. Don't need to worry about a Moore pipette, but we will have disposable plastic pipettes. It is a small little guy that is able to transfer small amounts of liquids. And again, it looks like with a bulb on it, and then down to it, it almost looks like an eyedropper. And then at the end, it comes down into a little dropper pattern. Okay, so we have disposable pipettes. Again, in the bookcases, take a look for them. Wash bottle, we'll put distilled water in here, able to spray water versus just trying to get it out of the sinks. Weigh boats, they're plastic boats. They're actually behind the spill kit sign, so be careful when you go looking for them. They're able to be used on our electronic balances. We're going to use these every time. Never put a chemical directly on to the electronic balance. You're going to put it on the weigh boat first. Ours are disposable, so one use, one garbage. Spatulas, I don't call these spatulas, I call them scoopulas. Half scoop, half spatula, we get scoopula. Same idea, it's going to be able to transfer small amounts of solid from the large container into what you are weighing. So look for scoopulas. We'll talk more about the proper use of them later. Beaker tongs. These are obviously used to pick up beakers that have been being heated. They're hot. Notice they are bigger and they have these round edges. Ours will actually have cloth around these parts here, but they are the bigger of the tongs. Bunsen burner, please watch the video on proper Bunsen burner use. Bonus points to anybody if you know how the Muppets are involved with the Bunsen burner. Evaporation dish, again, we're going to be able to heat solid compounds out of this almost to evaporation, hence the name. We will use a ring stand with a wire gauze and an iron ring with that use. But again, it's a large ceramic dish. A smaller ceramic teacup, we're going to call that a crucible with its lid, and we're able to heat things to very, very high temperatures. You'll be using these in one of the early labs. Clay triangle is again going to hook up with a ring stand, a Bunsen burner, and an iron ring, and the crucible fits right into there with its little lid. Crucible tongs. Okay, notice here's the difference. These little tiny tongs. Okay, you're going to pick up the crucible with them. They do not work on beakers. Triangular file. It's a file. It's shaped as a triangle. The major thing that we'll do with this is actually to score or cut glass when we're making our stirring rods. Ring stand. It's a big stand. Don't know why it's called a ring stand. It should just be called an iron stand, but it's not. It's the ring stand. We'll use it with all of its components. Here are some of the components. Iron rings. It's a ring made out of iron. Makes sense. Utility clamp, also known as a test tube clamp, will hold different things attached to the ring stand. Double burette clamp will hold a burette, which we'll talk about in a second. The other thing that you can do with iron rings, as we take a look back, you can put wire gauze right on top of it. So that's wire gauze goes onto the iron ring. And the other thing that you can do is, again, I can't draw, the clay triangle. Double burette clamp, again, goes on the burette. What is a burette? Here it is. It's pretty much a very precise, large graduated cylinder that has at the bottom of it a stopcock that allows liquid to go in and out. And these are used for an experiment called a titration. Okay, that's the biggest thing you need to know about a burette. It is used in a titration. It allows us very precise measurements of how much liquid was used in the experiment. We actually won't use these until April or May for acid-base titration, but still, it's a piece of equipment that you need to know about. There's the wire gauze that I was speaking of. It goes right on the iron ring. Strikers or flints used to light the Bunsen burner. And that is it. Please go back and review this. We'll take a look at the equipment in class again, but I do expect you to have at least a decent idea. This video is only 13 minutes long. You can view it one more time, take some notes. You need to know what it looks like, its name, and its use. We have a scavenger hunt on Friday. Good luck, and as always, if you have any questions, please ask. Have a good night.